Okay, so the first person is Miriam. She's an NYC member. So our goal is to attend this training and become expert in DevOps. So I try to clarify that you don't become an expert while you are being trained. You become an expert when you apply the knowledge that you have been taught. So what that means is that while the training seeks to cover as much as you should know in a practical way, to become an expert, you need to apply that knowledge again and again. That's where mastery will come from. So then the second person is Joy. And our goal is to be able to know automation, to know how developer and DevOps engineer work together, to be able to troubleshoot. So that's our goal. Then the next person is Olisa, and his goal is to gain mastery. Am I correct? All right. Okay, so the next person now, Stanley, okay. Okay, he wants to enhance his knowledge in tech. So how do you measure if you have enhanced your knowledge? Because enhancement is an abstract. Okay. It's all right. So let's have you. All right, so we have something here. His aim is to become a cloud computing engineer. All right. And I hope nobody will cut this your head. Okay, so Krista, let's have you. Then we have Matthew afterwards.
So I didn't get you.
Introduce yourself and your goal for attending this training.
Okay. Mine, I'll say it's because of money, because I love money a lot.
Okay, your goal for attending this training is because you love money. So how will you measure if that goal is achieved after the training?
I'm done with data analytics, so I just want this one as my second course.
All right, no problem. Matthew, let's have you.
Hi, good morning all. My name is Matthew Gisi. I'm a software developer. My goal is to become a DevOps engineer, hands-on DevOps engineer. Thank you.
So what aspect of software are you into? What language do you use?
So I do both front end and back end. Front end, I work with React, back end .NET. .NET Core actually.
.NET, right?
Yes, please.
Okay, do you have different software you have built that we can use for demonstration?
Some are internal to where I work, so they are not open source, yes.
But you'll be able to create sample for us that we can
definitely. Yeah, sure. I will.
Then we have another software here too that does Python. Hope you also give us some code that we can help you to deploy. All right. So it's a pleasure having you. Then the last person, I'm seeing TWE here. Can you introduce yourself and what you intend to achieve from this training?
Okay, good morning. My name is Oluwatosi Shemi. So I intend to know more about cloud automating and to just know more about DevOps, because I know it's a combination of development and operation. So I just want to know more about it.
All right. So you're welcome. One person is having challenge joining. She's saying is asking for passcode. I'm surprised because others are not using any passcode. Those online, can you be of help? You just click on the link and you're able to join, right?
Yes, that was what I did.
So I'm surprised the person is having challenge.
Maybe she's typing in the link.
Okay, just a minute. Let's be sure everybody is carried along. Just a minute.
My name is Iyare, Russell Iyare Omofoma. A student of 365. I'm here to be trained on how to use AWS DevOps and cloud computing. Thank you.
All right. Yeah, you're welcome. So we have someone that just walked in. Can you introduce yourself and what you intend to achieve from the training? All right. Okay, so you're all welcome. My own name is Wale Olajumoke. So I'll be the driver of this flight. So tighten your seatbelts as we embark on this journey. We are moving in high altitude. All right. So let's just, so that we can all be on the same page. I've said this before, but for the sake of emphasis, because it happens again and again. So 35 responsibility is to teach you in a way that you understand what you are being taught. Is that okay? So if I'm saying Linux, so is that responsibility to teach you in a way that you understand Linux and you can work with it. Is that okay? Then 2, if you have challenges, maybe I do something and you try it, it's not working for you. So it's a responsibility to help you out. Or you get home and you are practicing what you are being taught and you are facing some challenge. So you can reach out to us. Is that okay? So that's our responsibility. Your own responsibility is 1, punctuality. So class starts by 10. We don't believe in African time. We don't take traffic as an excuse. So you should calculate traffic before you leave home. So meaning you should leave home much more earlier, such that traffic will not be enough to stop you. Because we'll not wait for you because of traffic. Imagine everybody saying traffic, then the class will not be organized, right? So to ensure we don't do that. So ensure you are punctual by 10, you are here, or better before 10, you are here. If for any reason you come late and you are not able to follow the class because you come late, it will not be our responsibility because you are meant to come on time. So you'll be expected to watch the recording to catch up with whatever you miss. That's number 1. Number 2, practicing whatever you are learning is your responsibility. So meaning whatever we learn today, go over it before our next class. And that's one of the reasons why the class is not every day. So that you'll not be choking that you are not even able to go over what you are being taught. It's twice a week. So there's about 5 days left for you to go over what you are being taught. Is that okay? And even if possible, you can even research further on what you are being taught. Okay, I was taught this. So I go online, okay, no, is there any other thing that they did not talk about it that I need to know? Of course, we'll cover as much as we should cover. I'm just saying that you can even research further, to find out if there's more to what you're being taught than what you are told. So the first one is punctuality. The second one is practice. So there's no way you can master DevOps without practice, no matter how smart you are. Mastery comes through practice. People ask me, how do I teach DevOps? I teach AI. I teach software development, C#, Java, Python, Django, Laravel, PHP. All these things is not because I'm smarter than you. It's just because I'm somebody that is committed to practice. If 2 footballers, one is very talented, the other one is not talented. But one that is talented doesn't rehearse because he has the skill. But one that is talented, practice every day over time. With time, he will perform better than the one that is talented. That's how powerful practice is. Even if you are a slow learner, just do it again and again. It will become part of you. So that's the secret to mastering DevOps or any other tech skill whatsoever, even software and so on. The secret is practice. So if you're someone that, oh, I'm busy, oh, work. I'm not saying your work is not important, but if work is stopping you from practicing, that's letting you know that you cannot master the skill. So I'm telling us this ahead of time so that I can know what can stop you and make arrangements on how you're going to manage that. So if you go to work, maybe after work, you spend 2 hours every day, or use your weekend that you're not going to work to practice, just find a way around it. If you don't practice, you can't master it. So for those that said they want mastery, so I've told you the secret is through practice. You'll be given assignments after each class. please endeavor to do those assignments. If you don't do it, nothing will happen. We are all adults. But as part of your mastery, those assignments are meant to reinforce what you are being taught. Even if you don't solve all of them, at least you attempting them is a progress on its own, because you are tasking your brain. Then by the time you come to class and we solve it together, you're able to see what you should have done that you did not do well, so that next time you know a better way to approach it. So do your assignments, ensure you practice, and ensure you come on time. And please avoid distraction. If you're a business person, put your phone on silence. All the 25 missed calls, you can attend to them after the training. It's just 3 hours out of 24 hours. You have 21 hours to attend to your business. So I think you can be focused for that 3 hours. So we all pledge to abide and do your own part of the bargain while we do our own. So if that is clear, so let's get started. Please, I want to plead with us. If I'm doing something and you are behind, please stop me. So tell me, please wait for me so that I can finish what you are doing. Not that I will go ahead. I said, can I move on? And you are not saying anything and I move on. And I say, oh, what you did 30 minutes ago, that's where I'm still stuck. I will not be happy because I have to now go back, you know. So stop me immediately. You are not okay with the class. Either you are having challenges or you want to type something up. So just let me know that I should wait for you to be done before we progress so that we can all move at the same pace. Is that okay? So I like it where we are all at the same pace. As against, I didn't hear what you did 30 minutes ago, you know, that will not help us. So I think those are just the necessary things we need to bear in mind. So there's a lot to cover. So people say, can you cover all of this in 3 months? We've done several batches and we're able to cover it. And for those that have taken our other training, like software, I'm sure you know how our class, you know, it's like, it's hands-on. Of course, because this a training that some people are getting to know for the first time, we'll do a lot of theory for today. What is DevOps, what the theory that you need to know about DevOps, about cloud computing. Then from our next class, it will be practical till we are done. I'll just give you the overview, theoretical overview, then we go hands-on, we go hands-on. So with that, we will be able to cover in 3 months. And after the training, like I said, you are meant to practice. So I can give you tasks you can do, you know, to reiterate the things you have learned. There are tons of projects you can work on, but the concepts are almost the same. And I might be asking you questions, so don't feel shy that, what if I don't get the answer correctly? If you know the answer correctly, you're not meant to be here, right? You are here because you don't know the answer and you want to learn. So don't feel shy. Even if you get it wrong, at least that confidence to even try to answer is something on its own. Is that okay? So don't be like, and that's what I wanted to say. Oh. Why don't you say it? All right, so feel free. Nobody's an expert here. So I'll be asking you a question from time to time. What is this? Say what you know the way you know it. There's no right or wrong answer. If it's not correct, I will put you through on the right one. So with that, let's get started. You want to say something? All right. So somebody has a question. Maybe we should start with that question. And the question is, Krista, correct me if I'm right, that when you are done, should you apply for junior roles? Is that your question?
Yes, sir. Like when we're done, should we, instead of CV, should we prepare a resume and apply for junior roles? Or we should go for, or you suggest we should go for internship?
All right. Now, in tech generally, this is my personal advice. It's not like a rule of thumb. Don't apply for junior role. This is my own personal advice. Do not apply for junior role. What do I mean by that? When you finish learning and you want to get opportunity to practice, you can look for internship where you can practice. Do you understand? But you go into a company and say, I'm a junior DevOps engineer. I want to apply as a junior DevOps engineer. They are not likely to hire you. The chances is like 1%. Why? Because DevOps is something that requires resources. So nobody will give you their server and say, be experimenting with our server. I don't know if I'm getting my point. So that's why in this training, we'll cover as much as we should, and we'll give you other resources to practice further the same thing you have been taught. So my own advice is ensure that by the time you are done with this training, you are like intermediate, not like beginner. Are you getting my point? So if you apply for intermediate role, that still makes sense as against junior that they'll still be holding your hand and say, do this and do that. I don't know if you get my point. So whether you are doing software, you are doing DevOps, data analysis, or what have you, I don't recommend you applying as a junior data analyst, because that's what junior says. I'm still a novice. You are the one that will be putting me through what I need to do. But if you say I'm an intermediate DevOps engineer, they expect that at least there are some things you can do on your own. You just need a little support. Hope that makes sense.
Yes, sir.
But if you now see a role that says we want junior DevOps engineer, that's a different ball game. Hope you get my point. You can apply to junior because that's what you want to hire. But I'm saying if you are looking for a job, don't put junior DevOps engineer. Hope you get my point. Because
Yes,
that's like a no-no already. So you can just put intermediate if at all you want to put your level. Then another thing people do is they will do something like my skill set in Kubernetes 30/100, in Docker 50/100. That is also a bad way to present yourself. Because if you say 30/100, you already show that you are below average, right? Just say you have intermediate knowledge in so area. Hope you get my point. As against you putting percentage. The only time percentage will make sense if you are saying in Docker 90/100, Kubernetes 90/100. When your rate is very, very high, that's where percentage will make sense. Hope you get my point. But you're saying 50%, 30%, 20% is a no-no for me. I remember I interviewed somebody. I said, can you rate yourself in data analysis and this? He said 30% in this one, 20% in this one. I said, I'm sorry, you cannot hire you. You can't say, hey, sorry. That is just trying to be humble. You are being interviewed, you are trying to be humble. Excuse me. So for those that want to specify the skill you have, don't put percentage, except that percentage will be to your advantage, right? Okay, so that I hope that answers your question. When you are done, if you see internship, please go for it. If you see junior role, go for it. But when you are applying, don't apply as junior role, apply as intermediate. And that's the reason why you should pay attention to everything we are doing. Because if you know whatever we are doing, imagine what we wrote on our website. If you know those things, you should be able to call yourself intermediate, right? Hope you get my point. So that means you should challenge yourself that by the end of this class, I must go away as intermediate, not as junior. Hope that makes sense. And that's where personal practice also comes in. When you get to that Linux that we have taught in class, try and scatter your computer, turn it upside down. Let smoke start coming out. So that way you'll be able to. So that's to answer your question. If you have another question as I move on, you can pause me, ask your question. If you need to hold on with the question, I can tell you, okay, I'll answer it later. But feel free to ask your question so that you don't lose your thoughts. Or whenever I say, okay, is there any question you have penned down, then you can ask me by then. And some people are ahead of others. So please bear with us. If you are too slow for your liking, if you are feeling all these things are too basic, for the sake of those that don't know, you might still have to go over some basic things, right? So we'll get to your level and we'll move together at that pace. Okay, so let's get started. So DevOps training. So DevOps, what is it all about in your own words? So I need like 2 or 3 persons to tell me what do you understand by DevOps. I want to assess what you understand. Anybody? 2 or 3 persons. What is DevOps?
So let me just try.
Just a minute. Somebody is answering already.
Okay.
Should we just give Olisa a certificate? All right, that's a very brilliant one. So he said DevOps goal is to reconcile the operations and the development team so that they are all at the same level and at the same pace. Okay, Matthew, let's have you.
So, yeah, so similar to what I wanted to say, but before I say that, I don't know if the people in the room can be giving mics when they are talking. Yeah, so you
They can be given mic.
Microphone. So when they speak, we hear it directly from them. Rather than you translating it, it will also cut down on the time used in the explanation. Yeah, so I don't know, maybe you could work on that if that's not available. But for
all right, maybe you create some automation for us that will automate that process.
it's possible. So DevOps is an acronym for development and operation. So the development team and the operation teams working closely together to deliver on a project is what DevOps is all about, to the best of my knowledge. Thank you.
You're welcome. So just a minute, let me see if I can put them on speaker. Okay. If that will help, just a minute. I'm trying to make my own voice to be very clear. That's why I'm using personal mic, but let me put it on speaker and see if that helps. Okay, so we need one more person to share with us. What's DevOps in your own way, in your own word?
I think the development team, they plan, they code, and they do this. Why they expect to be the plan to first and to release the
Okay, that's the brilliant one. Did you hear her?
I was struggling to hear anyways, but
because people's audible level differ. So like maybe for now, we can make do with the summarizing of whatever they say. Just a minute. Okay, let's move on. So DevOps is a way to build and deliver software faster, better, and with stronger teamwork using automation, collaboration, and continuous improvement. Now, this is not like a global definition. It's just a summary of what DevOps is about. Then as we now proceed, we go deeper into it. So one of the goals that DevOps seek to solve is to make how you deliver software to be faster than the way it used to be. Is that okay? How to make it better, improve on the quality, and also stronger teamwork. Just like somebody said, operations and the development, you want them to collaborate, and achieve better results. So that's what DevOps seeks to, achieve. And how does he achieve this? He achieves it through automation. So when you automate things, it becomes faster and more reliable. It reduces manual, methods or manual error. Then collaboration. Since people are now working together, they achieve more. And then continuous improvement. So even though you have done it, you keep improving on it, over time. So that's what DevOps seeks to achieve. So there are tons of things we're going to cover. So I'm going to talk about introduction to DevOps and cloud. So what is DevOps and all of that? Introduction to cloud computing, introduction to AWS, IAM security. Then we do some practical lab. Then we look at how to manage costs. We look at EC2 fundamentals. Then we look at some other concepts on EC2. Then we look at Amazon S3. Then we look at networking with VPC. Then we look at different connection on with VPC. Then we look at auto scaling, how to scale your resources. Then load balancing. Then look at container. So when we are doing our projects, we'll make use of AWS container. But for the class, we'll focus on Docker. Then during the project, we learn how to use it on AWS. Then the same thing with EKS as well, AWS Kubernetes. So this will be used for our project, but for the class, we'll learn about Kubernetes generally. Then we'll learn about different databases on AWS, so which are same thing that extends to this. Then, so after that, those are the things we're going to learn about AWS. For some, what you need to know is a basic idea, like a theoretical knowledge. Why for some that relate to what you are doing, we need to do hands-on for those ones. Is that okay? So like those database now, is more of having understanding of different type of database they have and how they work. So we can just do maybe 1 or 2 demonstrations. So it's not like you have to demonstrate all the databases. So it's just for you to know which database that they have, when to use which one, the purpose they serve, then how to actually create them. So we can demonstrate that, for you to see. Then we move to Python. So why are we learning Python? I'm aware that not everybody have programming background. So for the sake of that, we're going to learn Python programming such that it will give you that foundation you need in programming. It's not that you're going to build Facebook with it or Twitter with it, no. But at least whenever you see function, you know this is a function, or if you need to write your own function to do certain things, you'll be able to write it. Is that okay? So we are going to learn about introduction to Python, variables, data types, how to put control in place, how to work with lists and dictionaries, loops, function, then advanced function, then how to work with modules, how to manipulate file, how to handle exceptions. So those are the areas we're going to cover in Python. So if this is a software class, they will delve into things like object-oriented programming, we'll delve into things like Django for backend development, building APIs and all of that. But like I said, the goal is not to make you a master of software development, but to give you enough to understand how programming works. And it's going to be practical because I'll give you different tasks, to do with it to ensure that you understand it and you're able to use it. So then we move to Linux. Now that we have foundation in programming, so the language of servers of the cloud is Linux. Of course, there are Windows servers as well, but you need to know Linux if you want to work in the cloud. So we're going to talk about introduction to Linux, the file hierarchy in Linux, how they are arranged. Then we talk about some commands in Linux. We talk about how to work with files and directories in Linux using different commands, how to process text in Linux, how to manage user, how to manage permission in Linux. And we're going to do some hands-on, you can see, practical labs. So at the end of the class, we should be able to manipulate all these things I'm talking about. Then file permission, how process work and how they are managed, different packages for different flavor of Linux, some basic system administration, and then some basic monitoring as well. Then we move to bash scripting. So if I want to carry out certain tasks on my AWS, I can write some code on my laptop and it will go to AWS and do all of those magic for me. I can even say be doing it every beginning of the month by so time. It will be doing that for you. So you can automate all of that using bash scripting. Then we move to version control. How to work with developers to handle version control of the software and also collaborate. So in real world, in organization, everybody might not be physically present. Some might be in US, another person is in Nigeria, another person is in UK. How do you collaborate with that other person to work with software? So I'm going to demonstrate that in class. So I will push a software. I will assume you are not physically here. So how are you meant to pull the code? How are you meant to commit the code? How are you meant to do all of that? So I'm going to do that. Then I'm going to show you how to put a mechanism in place so that where people are not meant to put their code, push their code to, they are not able to. You prevent that from happening as a DevOps engineer. So we do all of that. So learn about Git operations, what version control is about, how to connect to GitHub, how to push, how to pull, how to set up projects, branching and merging, then how to handle conflicts, how code are reviewed. So we'll do that. Then we now move to Terraform, which is infrastructure as code. So what do we mean by this? At the level of cloud computing, that's the first part we're going to do. That one, we're going to be doing them manually. We'll log into AWS and be creating those things manually. Set up a server, security group, VPC, and all of that. But at the level of infrastructure as code, you don't log into AWS to be setting those things manually. You write a code and say, this code, go to AWS and do all of this for me. You will set them up. And when you are done using them, you just say Terraform destroy. You will delete all the infrastructure that you have created, which is much more simplified compared to you going in and deleting them one by one. You might even forget to delete some. But because it's keeping track of all the things you are setting up, when it's time to delete, it knows all the things to delete, which make it much more efficient. So I'm going to learn about what is infrastructure as code, how do you get started with Terraform, what is resources, how to provision resources, how to use variable, what is Terraform module, and how to implement it on AWS. So I'm going to cover this. Then I'm going to cover Docker. Before now, developer will create software. It will work fine on the laptop. And by the time they deploy it in the cloud, there will be issue. It's working well on my own laptop, but it's the same thing you gave us that we put there. So that's what Docker seeks to solve, such that if you work on your laptop, it will work anywhere. So how is that done? So I'm going to talk about the concept of containerization and how it differs from virtualization. Then how do you install Docker? Then how do you work with Docker container? How do you work with Docker images? How do you create Docker image of any software they give to you? Then we are going to do that. Then how do you connect your containers together? Then I'm going to talk about how to work with volumes such that if your container is destroyed, how do you ensure that that data inside the container is secure? So that if another container is created, you can use that data and connect it to the new container that you set up. Then talk about Docker Compose, where you work with multiple containers, like front end is running in one container, back end is running in another container, database is running in another container, and yet they are talking to each other seamlessly. So that's where Docker Compose comes in. So I'm going to do that. Then we now move to Kubernetes. So Kubernetes is now that container. How do you now work with it on a large scale where you're running thousands of containers without, the headache of managing all of them? So Kubernetes will handle that for you. So we call it container orchestration. So how do you set up Kubernetes? There are different ways. You can set it up on your laptop, you can set it up in the cloud. So I'm going to look at different options you can use. Then different resources in Kubernetes. How do you now on Kubernetes? And then different ways to network in Kubernetes and expose your deployment. So we're going to do some hands-on for you to see how that works. Then we now move to Ansible, which is configuration management. And what that does is that you can use Ansible to control as many servers as you have at the same time. So let's say, for example, I have some files I want to copy to all my servers. Instead of doing them one by one, Ansible can just do it at once for all of them. I want to update the server, you update all of them at once. Anything you want to do, you just do it at once, which make it much more easier for you. So we talk about the concept of configuration management. How do you install Ansible? What are inventory? What are playbooks? How do you create your own playbooks? How do you use variable? So we'll do that. Then we'll now move to continuous integration with Jenkins. So we learn about what is CI/CD, continuous integration, continuous delivery, or continuous deployment. Then what is Jenkins architecture? How is the Jenkins architecture? How is it designed? Then what are the fundamentals of what you need to know? How do you build software with Jenkins? So they must have created the software. So how do you pass it through your pipeline? So build and test the software. And how do you integrate build tools like Maven into your CI/CD? So I'm going to talk about that. I'm going to create a pipeline to demonstrate how that works. Then we now wrap up with observability. So how do you monitor your infrastructure or your application and see how things are going? Then there's going to be a dashboard, like a UI design that will be showing you, what's going on in your infrastructure. So we use Grafana and Prometheus. So Prometheus, we collect those information about your CPU usage, all of that. While Grafana is where you visualize what is going on. Did you say something? Yeah, Grafana. So then these are different tasks you should be able to do, in the course of this training. So with that, let's move on. So now, before we actually talk about what is DevOps, how does it work, what are the skill sets you need to have and all of that, let's talk about before DevOps comes, what was on then, right? Before they start using DevOps, how are things handled? So that's what we call traditional IT. Traditional means the traditional way of doing things before DevOps came, so that you can see the difference between how it is done before and how it is done now. And if you want to recommend DevOps, you'll be able to know why you are recommending DevOps. Does that make sense? So the traditional IT before DevOps. So the traditional IT operation follow a siloed approach where development and operation teams work separately with distinct responsibility. So what does that mean? So let's say this is a company, 3365, and we have people that work in the development. So they will build the software, some will test it and all of that. Then we have the operations, those that we set up the infrastructure, the servers, that will put the software on the server, monitor the software and all of that. So they all work independently. So by the time I do my own, I hand over to the next person, I'm done. I don't care whether you are successful in your own or not. That's the way it is done before now. And that's what it means by silos. So silo means something independent of each other, like separated. So that's how it is done before DevOps came on board. So here are the characteristics of what happened back then. So development creates the code, operation deploys it and maintains it. So they just work independently. Sequential process. Now, things are done one after the other before DevOps, meaning the development have to spend like 6 months to finish building the software. Then you now give it to the test person who tests for maybe 2 weeks or whatever. Then now give it to the operation team who will deploy it, and that might take them maybe another 1 to 2 weeks. So you can see how long that takes. So that's how it is done before DevOps, and we call that waterfall methodology. Waterfall. Waterfall means when something is done step by step. You finish one stage before you move to the next stage. Before you move to the next stage, so we call it waterfall. Then, because of that waterfall, there's slow release. So the time it's going to take for that software to be ready for people to access it will take longer, right? And 2, when there's need for updates, you have to now go through all the process all over again. which will take longer time again. So mean that any small update will take long for you to, implement it and for you to be able to access it. Then most things are done manually. Then automation has not become, widely adopted back then. So many deploying and testing are performed manually. Then reactive approach. They wait for things to happen and go wrong before they now react to it. So that's how things are done before DevOps. Change resistance. So changes are viewed as something very risky. That's why you see some banks, they are still using Windows XP. Before they upgraded, it took time because they don't want to change. They are feeling that don't touch it, it's still working fine. Hope you are getting my point. Then limited automation. So then most things are done manually. Then separate tools, different tool sets for the development and operation. So then the tools they use are not integrated together. They are like the tools that the developer use are separate from the one that operation use. So that's the approach that is being adopted before DevOps came into being. Is this part clear to us? Is it clear? All right. I hope I'm not too fast. Am I too fast? All right. Okay, so that's the traditional way how it is done before now. So what are the challenges that happens with this traditional method? I don't know if this image is clear to us. You see people pointing finger, right? So what happens is, like I said, because it's done step by step, I do my own, I hand off to the next person. I don't care what happens, next. So when things go, everybody is pointing finger. That's one of the challenges or the major challenge that happens. So slow time to market. Please bear in mind, everything you are learning here, either software development training or DevOps or everything, the goal at the end of the day is to satisfy customer and make money for the company. That's the bottom line of everything. I don't know if I get my point. The company does not care about 5,000 tools that you can use. What they care about is how does what you know help our business, satisfy our customer, and get money from them. And this traditional method, it makes going to the market slow. Hope you know what I mean by that. Okay, I come up with an idea. Okay, I want to build an app where people can buy my product and all of that. And that app is taking me like 1 year. Then the business is already suffering, right? But if you can do it at a lesser period, at least let it go live. Then we cannot be adding other feature as we move on. In fact, that's even much more better because if you go and do it for 1 year and you release it, what it does not what they want. But if you do it for 2 months and you release a basic one, they can say, can you put it, can you put it? They're even the one telling you what they want you to put. So that way, by the time you are releasing it, is what they're already looking for, which is even a better approach. Then communication barrier was the order of the day back then. It works on my laptop. That's what the developer normally says. But it's working if I come and see it on my laptop. The customer, is it on your laptop? They will be accessing it. It's on the server. So those are the challenges back then. Deployment friction and failure. The version on the laptop might be different from the version on the server. So that might be another reason. Then blame game arise. Those are some of the challenges with the traditional IT. Doesn't mean that now that there's DevOps, there's no challenge. There are. But when you know those challenges they faced back then, the challenge they face now, you're able to balance the two. Hope that makes sense. So these are some of the challenges that characterize the traditional approach. So let's now move into DevOps. What is DevOps? Why are we using it? And how do we use it? So DevOps is a set of practice. Set of practice. Even though we're going to learn Docker, Kubernetes, Ansible, all of that, those things are not DevOps. Yeah, are you saying something?
I'm here, sir.
All right. DevOps are not all those tools. It's not Docker, Ansible, Linux. Those are not DevOps. DevOps is a culture, a way of doing things. In every tribe, they have their culture, how they greet, right? So DevOps is saying there's a culture of how we work. That is what DevOps is about. So for that culture to be able for you to be able to achieve that culture, then you can now use these tools to achieve that process. Hope that makes sense. So when you ask what is DevOps, DevOps is not all those tools that you are using. It is a way of doing things. So it's a set of practices. And those way of doing things, they combine software development and operation. They harmonize them together to shorten system development lifecycle. So meaning that to shorten how long it will take to build and get the software to the market. So the goal is to shorten it. And that's why at the beginning of the slide, I said the goal is for faster, better development, right? And delivery. So while delivering features, fixes, and updates frequently, reliably, and with high quality. So the goal of DevOps is not to do everything all at once. It's to release it when it's ready. That one goes. People start using it. You update the changes. That one goes. People start using it. So you do it, but you do it in a as frequent as possible, not delaying for too long. In a reliable way, not that by the time you release it, it crashes everything. So it should be reliable and it should be of high quality. So as much as automation and speed is important, you don't compromise quality as well. Hope that makes sense. All right. You have a question? All right. So it's a set of practices, cultural philosophies, then and tools. So the tool is towards a goal, is not the end. Hope that makes sense. The actual goal is for efficient delivery and timely delivery. So those two are just to help us achieve that end goal. Hope that makes sense. Because the tool will change. Tomorrow they may not use Docker again, another tool can come up. But it has not stopped the essence of what DevOps is trying to achieve. Hope that makes sense. It's like fashion will change, but your culture, still remain. Like you should always have respect. I don't know if I get what I'm trying to say. So that culture of DevOps will remain, even though DevOps has evolved over time. So what are the core principles of DevOps? Collaboration. Now, DevOps is not a place where you want to do I know it all, or you want to outshine your other team member. That's not the philosophy of DevOps. DevOps is a way of doing things such that if anybody fail in the team, if somebody fail in the team, everybody fail. I don't know if I get my point. You work together towards a common goal. You don't say because you are a good defender, you don't care what happens to other people. Hope you get my point. So everybody, if you are defending, nobody score, and your other team are not scoring, you will still lose because you still need to score, even though you are doing your own part. Hope that makes sense. So that's why you work together in DevOps. So don't be somebody that tries to hoard knowledge, or you just want to be the one that is being praised. That's not how DevOps work. Everybody succeeds together. So instead of those silos, everybody collaborates, towards achieving the end goal. Automation. So as much as possible, every manual task should be automated so that one, when you automate things, it does a lot of things for the organization. One, it minimizes error. Imagine I write a computer program now that will say 1 + 1 = 2, then +1 3, +1 4, and I leave it like that. You just continue doing that for me, isn't it? But if I'm to do it manually, at the point I might start getting tired and press the wrong thing. But when it's automated, you just keep doing it, on its own without your intervention. So automation helps you to minimize human error. Then two, automation saves time, because the time is going to take me to do 5 things. If I set that process in motion, it will be much more faster. So that's one of the principles. Yeah. When you say automation, it means something is done automatically. You don't do it manually. Okay, let's say, for example, let's say normal car, right? You go to your car, you start the car, you move the car. That's manual. But automation means like self-driving car. The car will just come, open, then you open it, you enter, it start driving you, because it is automated, it will be much more efficient. So let's now bring that into DevOps. So let's say, for example, when you build your software, you need to upload it to GitHub. Are you following? From GitHub, you need to upload it to your pipeline. Now, if I have to do that manually, that means you have to click, browse, select the file, upload it, right? Then when you select the file, you now push it to GitHub. Then from GitHub, you have to now click on somewhere where it will pull it. But if it is automated, as I finish writing the code and I say push, because it's automated, it will go to GitHub. Another software is aware that you have pushed something to GitHub. It will start its own process, take the software, test it. All of them will just continue the process like that until the final stage. I don't know if I get to my point. So automation means all the process has been created already. You only just to press this button. I don't know if I've seen this before, where somebody will touch a ball and that ball will go and hit something. That thing will fall on another thing. And that will fall on another thing, another thing, another thing, another thing. Have you seen something like that before? It's like a game. I don't know the name they call it. That's what I mean by automation. It means they have set that thing in place so that the one will trigger the other one, that will trigger another one, that will trigger another one. It is automated. Compared to me having to manually go there, push that one, then go to the next one, push it. That's the manual way. Does that make sense now? So automation means you have programmed everything, right? You have programmed everything. What should be done at this time? What should be done when the code is pushed here? What should be done after this one, pull it? What should be done after this one, pull it? Everything is already set in place. Is it clear? So that's what automation means. So replacing manual process with automated system. And because it is automated, there will be consistency. It will do it the same way. Then to be reliable and it will be efficient because it will save you time and minimize error. So I believe the first one, collaboration, that one is clear. Automation, do we understand what that means? Meaning you set up everything, you put a system in place that will manage everything automatically from beginning to the end. That's clear as well. All right. Now, the third principle of DevOps is continuous integration and continuous delivery or continuous deployment, depending on what you want to achieve. So what does that mean? It means whenever you build any software, it will not be in the perfect state. That means there will always be something to change, something to improve, something to correct. So continuous integration means as you change, as you add new feature, you continue to integrate them together. Hope that makes sense. So that's part of the principle of DevOps. You want to say something? Then as you're now integrating the updated version of the code, you need to now deliver the latest version of the code. So that's continuous. Then, if you now want to make it to go live, you now have to continuously deploy the new version of the code. Sometimes I might be mentioning certain words. I'm doing that deliberately so that I get used to those terminology. But if it's not clear, you can tell me to clarify what that terminology means. Is that okay? So when you say continuous integration, it's to modify the code. You keep integrating them together. Is that okay? As you are integrating them together, a new software is born. That's not the one you deliver or you deploy for people to access. And that's why they will alert you on your phone or your laptop, your app, that a new version is available. So that's how they do it. They continue to integrate the code. So that means the old code and the new changes they make are combined together. So that will be another version. So that can be version 1.1. Then when they make another changes or make corrections, 1.2. Then when there's now a major changes, that's version 2. Then 2.1, 2.2, 2.3. Major changes version 3. So that's how, so that's continuous integration of those changes, and you continuously deliver those changes or you deploy them. All right. Is that third point clear? This is to give you an overview. We still go deeper into each of them, but this just gives you like a summary of what DevOps entails. Then number 4, monitoring and feedback. So you monitor and see that everything is going as expected. Then you get the feedback. When the resources usage is higher than necessary, you get feedback. Then you can take necessary action on that. Then infrastructure as code. Instead of just setting up all those servers manually, you just write a code that automates everything for you. So that next time you need to do that again, the code is already available. Just run the code again and everything is ready, right? So this might not be a perfect example, but it's just an example. If you look at Nodus has been prepared to some extent so that you just need to put it in maybe hot water and it gets done, right? But imagine that nodule have to be prepared, not in the format it is, but you have to manually prepare it first before you get to the level it is. Then before you now cook it, that will be a longer process. I don't know if you're getting my point. So it means that in DevOps, most things that you are doing manually, you need to find a way to automate that process such that all I just need to do is say start, and this one will start. When it finishes, the next one will start. When it finishes, the next one will start. When it finishes, the next one will start. So that's what we mean by automation, right? So these are the 5 principles. At a higher level, do you understand what those 5 principles, what they entail? And if I ask you, give me one of those principles, you'll be able to tell me. Hey, people are now watching now. Okay, which one will I tell you? All right, so let's proceed. So this is the basic introduction of what DevOps is all about. I don't have to cram it, it's just a matter of understanding it. So in DevOps is a way of doing things, it's a set of practices, a cultural way of doing things. And that cultural way is about automating things, making it to be faster, reliability, making it to be better, right? And how we do this is through automation, through collaboration, through continuously delivering a better software. So just a matter of understanding it. So what are the history and evolution of DevOps? This part might be boring, but it just lets you know what happened as when it happened. So early 2000, so the foundation that will give birth to DevOps started in early 2000. And there was Agile movement in 2001. So I told you about a concept where the first stage had to finish before the second. What do we call that concept? Waterfall. So Agile came after waterfall. So after waterfall, then Agile started. So what is the concept of Agile? Agile means instead of you waiting for that step to finish before the next one finish, which is going to take a long time, we are saying, can we do a minimal part of that software? Then we move to the next stage, move to the next stage, move to the next stage. Then we start another part, move to the next stage. So that will be much more faster. Does it make sense? So I want to build a software that will have 10 features, right? For us to start using that software, how many features do we need for us to start using it? Okay, 3. Can we focus on that 3 features? So that will take us lesser time compared to 10 features. Does that make sense? So we'll do that 3 features. So instead of that 10 taking 6 months, the 3 features might take 2 months. So we have saved 4 months, right? So we release that software to the next stage, to the next stage, to the next stage, compared to having to wait for all the 10 features. Then when we do that, and we have sent it to the next phase, then we can start the second feature. Or from the feedback we get from that one, we make necessary correction, we move it up again. Then we go to the next one. Okay, let's do another 2 features, making 5, right? In addition to the 3 we have done before. Then that 2, because it's just 2, it will be faster compared to doing 7 at once. Hope that makes sense. So that's the concept of Agile. So Agile means you take minimal parts of a solution, you start working with it, you release that, then you get feedback, then pick another part, you do that, you release that. So emphasize iterating, so we call it iteration. So you deliver that, you go through the cycle again, you deliver, you go through the cycle. So that's the concept of Agile. So you collaborate with customer, because as you release the first part, you get feedback from the customer on the things they like, things they don't like, and that will inform the next phase that you're about to do. You put those feedback into consideration. Then you respond to changes. So these were concepts that were laying the foundation for what we know today as DevOps. So DevOps picked some concepts from Agile. Then in the mid-2000s, we have infrastructure as code, where instead of setting up infrastructure, when I say infrastructure, I mean server. Server is like a bigger version of laptop. It has CPU, it has RAM, all the features that laptop have. That's what a server has. So instead of setting them up manually, like installing things one by one, You just write a code that will set up that for you. So that's what we call infrastructure as code. We still go into all of these things at a deeper level. Then in 2000s, we also have system administration. We have system administration, and then there's a growing complexity in web operation, which leads to more frustration. So around that 2000, web is becoming more complex software, and beginning to come up. So there's a need for a better way to handle this. So in 2008, 2009, then it gave birth to DevOps. So the term DevOps emerged around 2008. So at Agile conference, Andrew Clay Schaffer and Patrick discussed Agile infrastructure. Then they talk about in velocity conference, they talk about how to deploy 10 times in a day. Before you can deploy, it might take weeks. So they come up with the concept that you know that I can deploy up to 10 times within a day. People will be interested. How? So that's what gave birth to what we know today as DevOps. Imagine what ChatGPT is doing today compared to before now. Before now, for you to write a story you will post on your website, it will take time, right? But now with ChatGPT, you just give some idea, you help you flesh it up. That you are releasing more stories faster. I don't know if I get my point. So the same way, now bring that into software. You're able to now release more software faster because you can now automate some of those processes and all of that. So that's how DevOps came to be. So early 2010, 2013, DevOps began gaining momentum. So there was a Phoenix project in 2013, and that illustrated DevOps principle through a fictional company's IT transformation. So there was a tool emergence in 2009, continuous integration. So Jenkins, start becoming popular in 2011. Then in 2014, DevOps became mature and became more solidified between 2014 and 2017. So then there was rise of Docker, microservices architecture. So microservices means instead of building software as a single software, you build them into smaller parts. They can now pack them together to form a holistic software. Just like Lego. Do you know Lego? All those bricks. I can use that bricks to form a building, right? So each brick is like a part of a software. Like ATM, you can withdraw, you can transfer, you can register an account, you can deposit. Imagine now break all of that into different parts, so that if one part have problem, it will not affect the other part, but that part will not work. I may not be able to withdraw because there's no money, but I can still transfer. I can still check balance. Do you get my point? So that's the concept of microservices, meaning a whole software, you now break them down into micro parts. Then those micro parts are now combined together to form a holistic solution. Of course, it has its own complexity, but that concept started gaining traction around that period. Then DevOps research, intensify. Then we have site reliability engineering by Google. The Cloud Native Foundation was established around 2015. So these were things that now make DevOps become globally adopted. Then DevOps evolved in 2018 to 2021. Kubernetes became mainstream. GitOps, DevSecOps, platform engineering, AI ops, they become they became mainstream. Then 2022 to where we are now. So we now have more evolution. We now have things like platform teams, FinOps, development and operation. We now have FinOps, which has to do with finance and with operation, just like development and operation. Then we now have GitOps. Then we have AI ops, a lot of improvement, a lot of new concepts, a lot of modification, adoption, as came in that has made DevOps evolve into so many other branches today. MLOps, people are not talking about MLOps. So those are into machine learning. That's ML, machine learning. Then they are now learning concept of DevOps, and that will give them MLOps, meaning a way to automate how you deliver machine learning, AI ops, FinOps, how you deliver financial services, financial solution. You combine that with DevOps, and that gives you FinOps. So these are how DevOps has evolved over time. Yeah. Now, like I said, the goal of what I'm doing now is like overview. Is that okay? So it might not be as detailed as you want, but as we move further, we'll go deeper. But I'll be picking your questions if you have them. So like a question, what is the meaning of deployment, right? Now, I have built a software on my laptop. Is that okay? That software, people outside of my environment, they cannot see it on my laptop. So I have to now take that software, copy it, and upload it to the internet. And that is what we call server. So there's another laptop somewhere that is connected to the internet. So when I now copy this, my own software that I've created, and I put it on that server, this is what we call internet. People can now access it from anywhere in the world. So the process of me copying it from my own system, so the server where people can access it is what we call deployment. Does it make sense now? Any other thing that you want me to clarify? GitHub. So we have what we call Git. Git is for version control and collaboration. Then Ops is operation. So when you now try to bring in automation or the concept of DevOps into versioning of your software for the purpose of deployment and all of that. So that's what we mean by GitOps. So GitOps is more of integrating concept of DevOps into operation and then software versioning. So that's what that is about. So a better way for me to explain will be, you have built a software, and that software, I need to deploy it. You know what I mean by deployment now? I need to push it to the server where it will go live for people to access. Are you following? Now, before now, all I just need to do is to push it to GitHub, then another process will now take over. But GitHub itself can now use DevOps concepts, DevOps tools to now undo all those processes without me needing external software. So that's GitOps. Like we're not integrating DevOps inside Git itself. Hope that makes sense. So that's what GitOps means. Then DevSecOps, meaning DevOps. In between them, you now put security. So that's DevSecOps. So if I'm into cybersecurity now, and I'm interested in DevOps, I can just focus on the security part of DevOps instead of the entire DevOps, because DevOps is very broad. I don't know if you get my point. So that person can be a DevSecOps. So his own concern is more of the security part. Does it make sense? For some people, they may be programmer. So they will find their own area to function. So it depends on your area of interest, because it's broad. So you pick where you want to specialize on. But it's good to have the general knowledge. Any other question? All right. So what are the key DevOps practices? I mentioned some of them already. It's just for emphasis. Key DevOps practices. Can somebody try? Key DevOps practices. Who want to try? It's okay if you don't get it, just try. From what I've learned so far, what are the key DevOps practices? Collaboration, automation, monitoring, CI/CD, monitoring and feedback, infrastructure as code. Okay, that's a brilliant one. If the answer is not what you say, it doesn't mean you are wrong. Is that okay? So version control, right? Continuous integration, right? Continuous delivery and deployment, right? So that means we can as well give you certificate. So it means you're already having the concept already, right? Yeah, that's good. Infrastructure as code, which is what she said. Configuration management, monitoring and logging, right? Microservice architecture. What is microservices? Micro, smaller size. So breaking a software into a smaller part that will still connect together to function as a whole. Does it make sense? So those are DevOps practices. Then security integration, which is DevSecOps. I've mentioned that already. So these are different DevOps practices. Those online, I hope we are following.
Very well.
Sorry,
Very
sorry,
well.
sorry.
Yeah,
I didn't quite see the previous screen, the key DevOps practices.
Okay, you did not see this previous one.
Yes, I think I
Okay.
missed it. Yeah.
So this is the first one, version control. I've explained that briefly. When we now get to GitHub, then we now go practical into detail. Hope that makes sense. This is just overview.
Okay, thank you.
Then we have these ones. Taking. Should I go on? Mr. Matthew. Mr. Matthew, you're asking me you didn't get the previous slide. So I'm asking you that, am I good to go now?
Sorry, I was muted. Yes, please. Sorry, I was muted.
All right. So those are DevOps practices. Now, DevOps Lifecycle and tool chain. So what does it mean? Lifecycle. Just like human being, you are given birth as a baby, right? You grow into a teenager, you go into a young adult, then you grow old, then the cycle goes, you go back to the sand, right? Maybe you're looking at me. Then the sand, plants, the plants grow, the human being eats that plant, you know, it's like a cycle sort of. So in DevOps, there's a cycle that you go from one place to another place, then you now start the cycle all over again. Do you understand? So the first stage will be the plan. And if you observe, this is ops. So whatever happens here is what the dev team handle. Then whatever happens here is what the operation team handle. But now they are not being integrated together. So they are not working independently now, but they are working together. Does it make sense? So in the life cycle, the first stage is the planning stage. So you plan what you want to achieve, what you want to do, how you want to do it, right? After you finish planning, then you code it. You code the solution. After you code it, you build it. After you build the solution, you test the solution. After you test it, you release it. Then it will be deployed. Then after it is deployed, which I believe you understand by now, then it will be operated upon. Then it will be monitored for feedback and ensuring things are working as supposed to be. Then you go back to planning again. So it never ends. That's why it's called a cycle. So you start from A, then you come back to the A again, you start all over again. Is it clear? And the next planning can be based on the feedback of the one that has been released. Maybe there are certain bugs, there are certain things that are not working as they should. Those feedback, you plan on resolving them, then you build those changes and you deploy. If they are okay, you plan on the next step, which is the next feature, you build them, you release them, you get the feedback, you make changes. Is it clear now? So that's DevOps Lifecycle. So if you ask, can you explain what DevOps Lifecycle is? I believe you understand how that works, right? I don't have to memorize it. The first step will be to plan what needs to be done. After you have planned what needs to be done, then you can now write it. After it is written as a code, you can now build it. Then after you build it, then you test it. Then when you finish testing it, you release it. Then when you release it, you deploy it. Then when you operate it, then you monitor, then you plan again. So that's why I said you have to practice whatever you're learning, you go over it. so that it sticks. And you should not cram it 13 times and say, okay, you plan. No, just talk about what you understand generally. Is that okay? So for this plan stage, there are a lot of tools that people use. And that can be where some people want to specialize. So maybe you are not a technical person, but you are good at planning. You can work at the planning stage. I don't know if you get my point. So in that stage, they use more of Jira, Trello, Asana, and so on. So that's what they use for planning. Then at the coding stage, so use like Git or GitHub, where all the code will be pushed and people will be collaborating with the code. Then if you don't use GitHub, then you can use GitLab or Bitbucket. But we will go with Git and GitHub because they are the most popular. Yeah. The plan will be done by the organization on what they want to build. So each member of the team will come on board. They onboard different team members, like the developer, the operations, and so on. So the planning stage will be based on what the organization wants to do. Do you understand what I'm trying to say? So what I'm trying to say is that the company want to build a solution. Okay, they want to build Facebook. They want to build something. They need to plan together with all the team members. We are not building a solution, but what we can do is I can come up with a code and say, okay, this is the solution that we have. Now we need to apply DevOps on this solution. I don't know if I get my point. At that point, they need to go and do research of what they want to do. Okay, let's say they want to build social network. Okay, can you go and search available social network that we have? What are the advantages they have? What are the weaknesses they have? What features we're going to have to add to our own that will be different? Then let's go and research how long is it likely to take us to build this solution. So all those planning stage differ from different organizations depending on what they want to do. But they need to plan the software they want to build, how long they are going to build it, how much it's going to cost them, all of those things. So go ahead.
So that planning, the it's like all these G's, they all have like software. So we are learning techniques, we are learning the other software here. So the planning, are we learning probably one of the planning here, or we are going to be learning that on our own for us to be able to use in a team, like when we get on the level that want to work with, then team members are not going to switch any of the channels.
Okay, I get you. Yeah. Asana. All right. Now, this will.
I think what she since we are going to learning at least 1, 2 weeks in all of these stages, if we are going to learn one of these tools for planning, that's what she's asking.
All right. Now, most cases, organizations have a tool chain they use for their own planning stage. So people use Jira, people use Trello, people use Asana. So the organization where you work, you have to know the tool that they use. And one, you can learn it. Or anyone you know, the concepts are similar. Do you understand? So what I'm trying to say is that you're not the one that will decide on the planning tool. The company decide that. For example, if they are already using Trello, you can't say what you know is Jira. You should take away their Trello and be using your own. It doesn't work that way. Hope you get my point. But the concepts are similar. Now, as regard using those planning tools, this is like a project management arm. I don't know if I get my point. So it's not something that we're going to focus on, but it's something you can learn. You can just go on YouTube and say how to use Trello or Jira. It's not something hard. It's like a software where when you register on the software, you can onboard people on the software. One of the projects I'm going to do is like that Jira or Trello or Asana. You're not getting my point. One of the software that we're going to deploy in this class is like that planning software. So maybe when I deploy it, I can show you that, okay, this is how they use it. I don't know if you get my point. But are we learning Jira as a software? No. But if I deploy that one, it will give you that concept of how it works. But like I said, it's a basic idea where when you log into that software, there's a place where you will add collaborators. So like you can add the developer, add the operation team, add the testing team and all of that. That's one. Two, there's a place for things that need to be done. And that's why I said they have to do research and all of that. So they will have several to-dos that these are 10 things you are supposed to do. Then they will now assign that task to different people. That this one now, it is your own responsibility. This one is your own responsibility, this one. Then each person will give reports on the feedback of the task given to them. Do you get my point? Then when they give you that task, if you are in progress with the task, you will move that task, move it to another section that says it is in progress. Then when you are done, you move that task to completed. So that's the basic way of how the two work. And like I said, when you get to that part, by the time I show you that, okay, this is how Jira, Asana, or Trello work, you'll be able to understand what I'm saying. Do you understand? But if you really want to know more, you can just go on YouTube and say how to use Trello. It's not something hard. It's just that it's not our focus. Because that alone can take us like, several, like 2 weeks to learn. Because that's some people's work, managing all those things. Anybody that does things like planning and all of that, they use it. Product manager, project manager, they use it. But like I said, by the time I show you that software we are deploying, you'll see how it works. What I just said now, I will demonstrate it to you. Is that okay? But on your own, if you want to learn it, you can just watch YouTube video on it. It's not something that, it doesn't require any coding or programming. It's just about tasks given to you, will be assigned to you. Then you'll be given updates on what you have done. Then you move that task to the next stage that I'm already doing it. Then when you are done, you move it to I am done. So I hope that answers your question. So the next one is the code. Now, in this code, the software itself needs to be built. And we are not going to be building the software because this is not a software development class. So we are not going to be building the software. But what I can do for you will be, I can just demonstrate how the developer come about that software. I don't know if I'm getting my point. Like, okay, they install something like this, they install this, they install this. That's how they come up with the software. This is not a software class. So if you want to know how to build software, then you have to do software training. That's like a 4-month course on its own. Do you understand?
So if we are not learning how to do, that means after the software developer.
Exactly. That's where you come in. Exactly. But you'll be part of the team from the beginning. Because like I said, it's not about do your own. When it's my turn, you call me. You are part of the team. But just that the software has to be built for you to start your own process. So after they have built it, then you come in with the Git and GitHub where you collaborate with the code. They push the code to GitHub. You, the DevOps engineer, can now pull the code and start doing your own magic. Hope that makes sense. So we'll be using Git and GitHub, but you can use GitLab or Bitbucket. They do the same thing. Is that okay? Their interface looks similar. How they work is similar. It's just little differences. Then we now build the software. When I say build, I'm not saying you write the code. I mean the code that has been written will be packaged together. That's what I mean by build. It will be packaged. So I'm going to be using Jenkins. So other people use Circle CI, GitLab, GitHub Action. So they do the same thing. It depends on the one you are using. And they work in a similar way. So if you know Jenkins, it should be easy for you to port to another one. And one of the characteristics of a DevOps engineer is you should be flexible. You shouldn't be somebody that, how we do it now is how we should do it in 10 years' time. Don't have that kind of mindset as a DevOps engineer. Be willing that when things are moving, you are willing to learn something new. Me, I like it because I'm bored. If I'm doing the same thing throughout the year, no creativity, no innovation. But I like DevOps because new things are coming up. Then testing. So I'm going to do testing with Sonar Cloud. It will check for vulnerability. It will analyze our software for us. Some use Selenium, JUnit, PyTest, and so on. Then we move to deploy. Deploy is now you making it to go live on the server. So I'm going to be using Kubernetes, Docker, Terraform, and Ansible. Then operate. So still use Kubernetes to operate it as well. But if you are not using Kubernetes, you can use Docker Swarm, or you can use AWS, Azure, or Google Cloud Services. They have their own Kubernetes that is customized for their platform. So at this point, let me point this out. There are two types of DevOps. There is platform-specific DevOps, and there is cross-platform DevOps. What do I mean by that? AWS, they have their own DevOps tools that they use. And that tool can only work on AWS. It cannot work anywhere else. So if you learn that tool, you will become AWS DevOps engineer. Do you understand that one? It's not clear. AWS, all these tools I'm talking about, GitHub, Jenkins, Terraform, they have all of that too on their website. If you use that tool can only work on AWS. It cannot work on another website. So if you now use that tool, you learn that tool for DevOps, you can become AWS DevOps engineer. Is that one clear? Microsoft, they have their own called Azure. On that Azure, they have all the DevOps tools that does everything that you need to do. If you learn that tool, you become Azure DevOps engineer. But all the tools cannot work on another platform. Is it making sense? Then Google have their own, Google Cloud Platform, GCP. All their tools as well. You work on Google. You cannot work on another platform. If you learn it, you become Google Certified DevOps Engineer. Now, that has pros and cons. The pros is that all the tools on the platform, right? But the disadvantage is that when your company wants to move, all the tools will be abandoned. So we are learning cross-platform DevOps such that it's not tied to a particular platform. I can use that tool on Azure, I can use it on AWS, I can use it on Google, I can use it on DigitalOcean or any other platform. Okay, it's not clear. Okay, let me explain. You know GitHub, even though you don't have to use it, you have heard of GitHub before. GitHub is where you put your code. Is that one clear? AWS, they have their own version of GitHub. It's called code commit. Code commit. Are you following? When you write code, where you keep your code is what we call GitHub. We'll still get there. This is just overview. So when you write your code now, you can push it to GitHub where others can also work with the code. Is that one clear? I'm saying AWS, they have their own version of GitHub. If they don't want to use GitHub, they have their own version. They call it code commit. Are you with me? Now, that code commit only work on AWS. That means don't have AWS, cannot use it. And for GitHub, I can connect GitHub to other platforms. Are you getting me? Which one will you prefer to use? The one only on AWS or the one that can work with any other platform? So that's what I'm trying to say, that the DevOps we are learning, the tools we are learning are not tools that are meant for particular platforms specifically. The one that can work with any platform is the one we want to focus on. Is it clear now? All right. So instead of us learning code commit, we'll be learning GitHub. Is it clear? AWS, they have what we call cloud formation. Cloud formation is when you write it, you go to AWS and create all those things for you. But it cannot work for any other website. So we are learning Terraform that can write the code, do it on AWS, do it on Azure, do it on GitHub, do it on Google, and so on. Which one do you prefer? CloudFormation or Terraform? So hope you understand now. All right. So, yes, go ahead. No, just the code. We never reach your level. I know. No, we are not writing the code. That's the software. It's the developer that will write the software, the code. And we've agreed now from Git and GitHub is where you are starting. When the person write the code, they will push it to GitHub using Git. Git is like what sends the instruction. Then GitHub is where the code will now be physically. Then you will not come on board then. All this is you're asking me as we move on, it become clear because we'll now start demonstrating it. Everybody will start collaborating with each other, all of that. You are not the one to build. It's the developer that will build the software. Some people are so scared to build.
Like I'm looking at this.
Yeah.
This test now, am I going? Is it development that?
The DevOps engineer is the one that will do this build. And I've explained, this build is not writing code. That is the code here. This build is not to package the code together as a software. And there's a software that will do it for you. You are not doing any code there. Is it clear? Then that software too will test it for you. Right? But I won't use the word society because it's not like people that live in one place. Yeah, it's principle, yes, that's correct. The word society is what I'm struggling with. But what you're saying is that there are people that have agreed on how things should be done, but not like they have their own separate society from our normal society. It's a philosophy, it's an ideology. What you're saying is right. I'm just looking at that word society. Okay, maybe we can say it's a community that shares similar ideology, similar values, similar way of doing things. Does that help? So that community, the ideology they share, different companies can adopt it and be using it in their own company. Is that okay? Have I answered your question? All right. So then the build, we use Jenkins. The test, we use Sonar Cloud. For the deploy, we use Kubernetes, Docker, and Terraform. Then for the monitoring, we use Prometheus and Grafana. So we have other tools like ELK, New Relic, Datadog. In fact, there are hundreds of tools, more than hundreds that you can use in DevOps. But what matters is most of those to do the same thing. Just pick one and know how to use it well, then you are fine. So you don't have to know everything. It's like language. Do you know how many languages we have in the world? But at least you know English and it's helping you to communicate. Then because you say, okay, I just want to learn another language, then you can pick another one. So the same way, when you have learned one, let's say here now, maybe you know Jenkins very well. You can say, okay, I want to pick another one, maybe GitHub Action. Since the concepts are similar, it's just about what I do here this way. How do I do that same thing here? So you can learn other ones, but don't feel that you must know everything here before you can say you know it. Hope you get my point. GitHub and Git Bash. Git Bash is just like your Git. That Git is your Git Bash. Git Bash is where you give the command of what to do. GitHub is the physical place where the actions are taking place. Right? Are we good? Go ahead. Since it's bothering you, you should ask.
I'm thinking monitoring like maybe okay, let's take an example, a website that let me use WhatsApp. use space, where people are now saying nonsense. You have to upgrade this thing of probably it is not moving fast, it is close to all those stuff. So I was thinking that's what you meant by monitor when you meant something. But now that you're using information, I mean we're not monitoring.
You're not bothered about what people say. What you're monitoring is the server running as it should? Is it almost full? And we need to quickly intervene. That's what you're monitoring. Hope that makes sense. So maybe how much they charge you this month? $50. The next month they charge you $90. You have to monitor what goes wrong. Why the change? What is consuming our money? So you have to monitor all of those things. You are not monitoring what people are saying in the software. No. Hope it's clear now. Yes, now. They are in business to make money, but some of them are open source. Open source are usually free. When it is not free, it will be very cheap. Some are not free, but they are very, very cheap compared to if it's not open source. And the code most times are available. So you can take the code, change it to whatever you like. I think DeepSeek did that. They create their own ChatGPT, then they make the code available to people. Say, this is the code we used to create it. Do it whatever you like with it. That's what threatened ChatGPT back then. And stock price started crashing. But everybody, they accept each other now. That's why some things in the world, you cannot stop it. No matter how fantastic you think you can think, because you will destroy many things. So, except you now align with people that can influence it ahead. All right, so those are the tool chain and the life cycle. Is it clear? So what are the benefits of DevOps? Benefit of DevOps. Reliable deployment, speed, others now.
Reduce time consumption.
High quality. He said yes. But
Reduce time consumption.
You know, it saves time. It saves time. So faster time to market, right? Improve collaboration and communication. Higher quality and more reliable release. Increase operational efficiency, better recovery time, enhance security through automation and consistent practice. I'm using different words, but still mean the same thing, right? So what are the challenges that DevOps is likely to face? Oh yeah, it's your turn now. Me, I've been teaching you. Oh yeah, I want to learn from you. What are the challenges DevOps is likely to face? Anybody? So this company want to adopt DevOps. What challenges are they likely to face? Cost, Not getting the right feedback. Okay, one more person.
Skills challenge, developers or practitioners skills levels challenge.
Sorry, I didn't get that. Legacy system. I don't want to talk since. So you are using whole technology that cannot even make sense with DevOps tools. That's why if you want to build mobile app, there should be minimum type of Android phone you are using. Like some Android phone, if you try to install some mobile app there, it will not work. Because that your phone is a blast from the past.
Sorry.
I will answer what he said. So, cultural change. The biggest hurdle in DevOps is it requires leadership, support, and mind shift. So imagine in Nigeria now, want to automate all the process in Nigeria. Do you know how many government workers will fight back? Do you understand? if you want to automate all the process in Nigeria, you know that many public servants, many government workers, they will fight back. Because one, how they are doing it now may be benefiting them in some way. I don't know if I'm getting my point. Then two, getting the buy-in of the leaders to even agree to do it in the first place may be a challenge. So there may be no will to want to automate things. Maybe because they are benefiting from the way it is at the moment, or they are afraid that they automate things, it may lead to loss of job or some things like that. Is that one clear? So that's when you want to bring in DevOps into an organization, there'll be a change in how they do things before than how they will be doing it now, and there'll be resistance. People don't want to change how they are doing things. Leave it like that. We don't want, a new way of doing it. So that will be one of the challenges. So when I call it challenge, I don't mean DevOps is bad. I'm saying likely challenge that might come up. People don't want it to adopt, not wanting to change. That may be a challenge. Hope you get my point now. Miriam, is it clear? Number two, tool integration. Creating a seamless tool chain across different systems. Now, the system they are using may be different. So it might require you having to adjust existing DevOps tool to fit into the system you are using currently. Especially if it's the customized software and not something that is, like the regular workflow, that uses the regular workflow. Legacy systems, which is what he said. Legacy system is when you have an old system. For example, people don't use certain version of Python again. Imagine your own software is now using that version of Python. So adopting DevOps will be challenging because they may have to upgrade that software to a latest version. Because if you don't upgrade it, that's a security risk, which will defeat the purpose of DevOps. Is it making sense now? I hope what he has is clear now. Then security concern, balancing speed with proper security control. So some people are concerned that, okay, if you want it to be fast, how about security? And that's where from get-go, you have to factor in security in whatever you are doing. Is that okay? So these are things you might need to pay attention to for any organization that wants to adopt DevOps, that this might be a challenge they will face. If their software is too old, then they may have to upgrade, and that may take some time, some resources to achieve. So I hope you have not pictured what I just opened now. What's the difference between DevOps and traditional IT? Give me one each. DevOps and traditional IT, what's the difference? Okay, this is done in traditional IT, this is done in DevOps. So collaboration and teamwork instead of silos. Oh, where's the certificate? Oh yeah, another person. So faster, shorter time, excellent. Any other person? Automation instead of manual way of doing things. Microservices. So you split the software into smaller bits instead of just a single software. Even if it's a single software, if there's anything having issue, it will affect the entire software. That's another disadvantage of not using microservices. Yeah, that's a brilliant one. So in terms of culture, separate teams with different goals in traditional IT, but in DevOps, collaborative team with shared goal, right? The process, it is linear and sequential, one after the other. But this one is a continuous process and it is iterative. You go over all over again. Speed, it is slow and very cautious. This is one, it is fast and it's adaptable. You can adapt it to your environment. Risk, there's a larger risk and infrequent changes. They don't make changes often because of risk. But here, the risk is small and changes are done often. Then automation is limited here. But here, in fact, automation is extensive. That's the what to do. Feedback are delayed here, But yeah, feedback are immediate because there can be email notification when anything happens. When your price is going beyond what you budget for, you can get notified and you swing to action to find out why. So immediate feedback. Recovery is slow and manual. Here, recovery is fast and automated. Here, stability is more important than speed. But here, there's a balance between stability and speed. Hope this makes sense. So if you want to convince an organization why DevOps is the way to go and not confuse them, you know what to do, right? All right. So what are the of DevOps? So I'll just summarize this. Cost reduction. Now, when I say cost reduction, I don't mean DevOps is cheap. In fact, DevOps is expensive. But cost reduction in the sense that if our server is taking care of 1 million people, are we following? In DevOps, if that 1 million shoot up to 5 million, it can automatically scale to accommodate that 5 million. Are we following? If tomorrow the number now reduced back to 1 million, it will destroy all those infrastructure that are excess so that you are not paying for them. But in traditional IT, you have 1 million people, you're not going to acquire more servers for 5 million. By the time they no longer patronize again, what do you do with the other one? They are just wasting your resources. Hope you get my point. So that's what I mean by cost reduction. That you only pay for what you use. When you're not using it, you can do away with it to save cost. And when you need it, you hope you get my point. So it doesn't mean DevOps is cheap. So infrastructure optimization, automation, and cloud resources, you do infrastructure costs, it reduces downtime, your resource is more efficient, it streamlines operation, then revenue growth. So DevOps also help you to grow your revenue because you are now able to deliver your software faster for patronage and improve customer retention. When your service is good, you retain the customer and more money comes, right? Competitive advantage. While others are spending 6 months, 1 year to build their own, you are already penetrating the market. New business model. You can quickly bring in new concepts because you are innovating very fast. Operational improvement, speed and agility. You can deploy even 10 times in a day. Lead time for changes, feature implementation. You can even deploy two and be testing their performance and compare. So all of these are how DevOps benefit business. Hope that makes sense. So if an organization says, okay, can you write us a proposal on how adopting DevOps will benefit us? So these are some of your points, right? Or they ask you at interview, can you tell me what are the benefits for adopting DevOps as an organization? Although as a beginner, working in a place where they already have DevOps is better for you. So you're not the sole person implementing it for them. I don't know if you get my point. So at least you also learn alongside with the seniors that are there. Hope you get my point. Compared to you going to a company that they don't even know DevOps at all. And that's okay, you are the one that will set up all our infrastructure, everything. As a beginner, that might be overwhelming for you. But if you work in a place where they already have, in place, so you learn more, then as you grow, you can now help other people to set it up and charge them in millions of dollars. Stability and reliability. So it's more stable, it's more reliable. The failure are reduced, high availability, consistent environment, risk management. You're able to minimize risk. Organizational transformation, you're able to transform the culture of that organization by breaking that silos, make them to work together, talent attraction and retention, knowledge sharing, scalable teams. So these are business benefits. Performance metric, deployment frequency. Okay, I think I've said this already. So real-time example, Amazon, they deploy code every 11.7 seconds. Do you understand? Meaning, if there's any changes, they can, within seconds, they can just make it go live. As against spending a lot of time. Native uses child engineering to ensure resilience, saving millions in potential downtime. HC reduce deployment time from hours to minutes, enabling 50+ daily deployment. Target, another company, they reduce release cycle from months to weeks, leading to better customer experiences. Is it making sense? All right. So careers in DevOps. So if you're looking at what role can I go for in DevOps, you can become a DevOps engineer. You can become site reliability engineer. You can become platform engineer. You can become cloud engineer. You can become DevSecOps engineer, infrastructure engineer, release engineer, automation engineer. So those are different areas you can specialize on. Even though you are doing DevOps, you can be a cloud engineer. Hope that makes sense. You can even be DevOps architect. So what are the skills required for DevOps career? So you need the following skills. Technical skill. So infrastructure as code, automation, CI/CD, programming, monitoring, security. So we are going to be covering this. You need soft skill, communication. You cannot teach all of this one, but you have to also build them, right? So that's why when I give you task, I expect feedback. That's part of communication. Documenting all the steps you follow so that your team member are able to go through it and know what to do. Explaining complex concepts to a non-technical person. So if somebody asks you what is Kubernetes, don't say, it's very technical. No, you should be able to explain it. That person that is not a technical person understand what Kubernetes is all about. Is it clear? So that's a skill you need to develop. So that when you're talking to stakeholders, to management, to customer, you're able to break it down for them. Right? And say, if you go by what you are saying, that means we need to create more server, and that will cost us more money. However, it is a good thing to do. Reason being that if you don't have additional server and this server break down, people will not be able to access your software and you will lose money. So that person can reason with you, right? You might be talking about auto scaling, load, the person cannot understand what you're saying. So you have to be able to break it down. You need problem solving skill. How to analyze, how to debug problem, how to think holistically about the system and how they connect to each other. Project management, understanding the agile methodology, how things are done in an iterative way, how to manage time and prioritize what is more important. Business acumen, understanding how does what I'm doing affect the bottom line in the long run for the business. Cost optimization, how do we ensure that even though we want excellent delivery and efficiency, how do we still ensure that we don't go at a loss? Risk management, continuous learning. This one is very important. You need to learn how to adapt to new technology. Follow industry trend. Self-directed learning. Before now, there was no ChatGPT. But now ChatGPT have changed how almost every business are run, right? I heard that TVC, they now have AI that is casting news. You have not heard about the news. I just Google news, AI newscaster on TVC. You will see the news. So that means newscaster have to buckle up, right? Because the AI can even say it in different language. And you only know one language. So does this make sense? Now, I'm not saying you should know all these things now. Hope you get my point. I'm just saying, if I ask you, okay, what are the things I even need to succeed in this career? So these are some of the skills you need. Is that okay? Maybe I hope you're not getting overwhelmed. And the beauty is that if you can learn this very well, there's money in it. You'll be well paid because not everybody is willing or ready to learn it. So there are different certifications you can do. So you can do AWS certification like cloud practitioner, You can do SysOps administrator. You can do solution architect. Then for Microsoft, they have DevOps engineer. And you know why you will not be able to do this, right? And this one. However, because the tool we are using is similar to their own, you can use that knowledge to learn their own if you are still interested in their own certification. I don't know if I'm getting my point. How GitHub work, the one we're going to do, is similar to how their own code commits work. How Terraform work is similar to how CloudFormation work. It's just the code that will be different and the terminologies, but the concepts are similar. Is that okay? Then if you're into Google Cloud, these are different certifications. Now, this is where you should focus on, since you are learning cross-platform. So these are certifications you should focus on. Certified Kubernetes Administrator, Certified Kubernetes Application, Certified Kubernetes Security Specialist, Docker Certified Associate. So you may want to consider this Docker and this Kubernetes, maybe this one or both of them. But this one is good for you and this one. If you have these two, they are as powerful as AWS DevOps Engineer, Microsoft DevOps Engineer. Those two, they are as powerful as that. Is that okay? Because they can work on any platform. Then if you want to go further, you can do Jenkins certification, you can do GitHub Action certification, you can do Red Hat certification. But the one that are more important is this one and this one. But if you want to flex your muscle of Linux, then you can do Linux certification as well. And so that Linux, I have mastered it. I've mastered it. That's what I'm saying. That I'll recommend these two, but in addition, you can do Linux certification as well. So this one is Ansible automation. Then we have Red Hat Linux certification. In fact, there are even different variations of Linux certification. Then under security, you can do DevSecOps, you can do Cloud Security, CSSP, you can do Certified Information System Security Professional. Then you can do certification on Terraform if you want. It's also a good one. Then if you're into monitoring, you can do certification on Datadog, New Relic, Splunk. These ones are not code inclined. So if you're not a person that like coding at all, you just want to be monitor what's going on, then you can just focus on that one. Then general DevOps. We have DevOps Institute certification, Linux Foundation, Certified DevOps Engineer, DevOps Professional, Linux Professional Institute DevOps Tools Engineer. So you might consider some of these as well, if you are interested in certification. But hands-on knowledge is priority. Certification is just to package yourself, right? Because if you have certification and you're not good, even if they hire you, what will you do? Right? So be good, then brand yourself with certification. They can hire you without certification. What matters is you can deliver. That's what matters. They vary, but they are not cheap. Like $100, is it cheap or expensive? You can work towards it. It doesn't have to be immediate. So the summary of what we have done, you have learned fundamentals of DevOps, the practices of DevOps, the lifecycle of DevOps, career in DevOps, skills required in DevOps, and certification in DevOps. Yes or yes? All right. You have a question? All right. So we move to cloud computing. So what we're going to do is we use the remaining 45 minutes to learn the theory of cloud computing. Then our next class, we start practical. Are we good? Or is it boring? What is cloud computing? Who want to answer? What is cloud computing? Nobody. Storing data in the cloud. Okay. One more person. What is cloud computing? Okay, that will take me to the next question. What is cloud? Because one politician said, we need to go to the cloud in the sky. So what is cloud? Storage. Where is the storage? Where is the cloud?
Server hosted somewhere else. So you are granted access to that server. So let's say AWS now is a cloud platform, cloud provider platform. What they do is they have their servers as the customer. They grant you access to the server at the cost. You don't use the server anymore. You can just use the one that you have.
And you said we should not give you certificates. All right. So cloud computing deliver IT resources on demand via the internet with pay-as-you-go pricing. So when you say cloud, we are not talking about the sky. We are talking about physical server that is located somewhere else. So the concept of cloud means it's not physically present. You have to go through the internet to access it. That's what we mean by cloud. Is it clear now? Not in the sky. It has storage, it has servers, different things. So cloud computing deliver IT resources on demand. On demand means only when you need it. Traditional IT, you have to buy the physical server at your office. You have to use AC to be cooling it down. You have to have 24-hour supply, power supply. You have to hire professional that will be managing it. You have to pay for the rent of that place. So those are costs of traditional IT. And in case there's a disaster, there is fire outbreak, what happens in traditional IT? You lose everything. But with cloud, anything you have with them, they can have a copy of it in another region. So like if this region have problem, you have your data in another region. So that's the advantage. So you pay as you go. When you're not using it, you don't pay. When you're using it, you pay. Just like Uber. Instead of you having your own car, which is traditional IT, you just order Uber when you need it. Then you pay. When you're not using it, you don't pay. Hope that makes sense. I don't take as much for maintenance of the car. Like servicing, fueling, it's not my responsibility. So with traditional IT, you maintain, do all of that. But with cloud, you don't do that. You only pay for what you use. So we are back. How does traditional IT work before cloud computing? So traditional IT typically consists of on-premise hardware and software that organizations purchase, implement, and maintain by themselves. So like banks now, they will buy physical server. They will have what they call server room. Yeah, so that's where the server will be, all the activity going on there. Now, the fact that we're talking about cloud does not mean traditional IT does not exist again. Some companies still use it and they have their reason. And we're going to touch on that. So what are the characteristics of traditional IT when it comes to cloud computing? Capital expenditure. You are responsible for the cost of that server. You buy it with your own money. And that can be expensive. Number two, fixed capacity. Whatever you buy, that's what you are capable of carrying, right? You cannot carry beyond what your server can carry. So that's for traditional IT. But in the cloud, you can scale as much as you want. Physical infrastructure. So you have the server, the storage, the networking, everything physically in your data center. Internal IT staff, they handle all the maintenance, all the upgrades, they are being done by your staff. Hardware refreshes every 3 to 5 years with lengthy procurement process. So if you need to change things, you have to physically go to the market and buy those parts and come and fix it. That's for the traditional way. Scaling challenges, because your building is limited, your server cannot go beyond the building. So you now have to rent additional spaces. Then recovery, like I said, disaster recovery requires duplicate hardware and facility. So if you don't have physical office where you are backing up elsewhere, then you happen to this physical one, then that won't be affected. So I've talked about this. The advantage of using traditional way, you have complete control because everything physically there with you, right? Potential for high security for sensitive data. If you have a data that is very sensitive, no other person can have access because it's physical. But if it's via the internet, they can hijack it. No dependency on internet connectivity. So that's advantages. Predictable long-term cost after initial. So if you invest in it physically, at least you now own the building if you're the one that build it yourself, right? So if the company is doing something that is very, very sensitive, they might want to consider IT, traditional IT, having their own physical sense. So what are the disadvantages? High upfront cost. All these things you have to buy them yourself, expensive. Maintain everything yourself. Implementing things, resources, focus on managing what is existing as against innovating in a new way. If you're not the one that owns the car, you can innovate. But if you have your physical car, you are limited by what the car can do. I don't know if I'm getting my point. Example, if I don't own a car and I want to go for an event that is very, very important, I can order which one now? Give me that big cars. G-Wagon to take me there. That's innovation. I don't know if I'm getting my point. But I cannot physically go and buy G-Wagon because my resources is limited. I don't know if I'm getting my point. I'm saying with cloud, you can innovate and go and get something complex to serve your purpose because you are not paying to own it yourself. You are just like hire it. When you are done, you return it back. So risk of obsolescence. So meaning it can easily go obsolete because new technology can come up that will draft the one you have acquired. But if it is cloud, just move to the new one. You're not paying. You don't own those things physically, right? So what is cloud computing? Why are we learning it? And how is it done? Cloud computing is the delivery of computing services. When I say computing services, I'm talking about servers, storage, database, networking, software, analytics, intelligence. Then you do all of this over the internet, which is what we call cloud, not sky. So to offer faster innovation, flexible resources, and economies of scale. So that's what cloud computing is about. When you access IT resources via the internet. So what are the characteristics of cloud computing? On-demand self-service. It means you only make use of it when you need it and you can serve yourself. You don't need any human interaction. Is that okay? Just like Uber, I can just demand for a car whenever I need it, right? Just like Netflix, I can just subscribe and start watching. I don't have to call their representative. Hello, I want to subscribe to Netflix. No human interaction. Pay with your card, you start watching it. So it is a self-service. You don't need to interact with anybody. Except you now need their support for something. Then broad network access. It means services are available via different platforms like your phone, your PC, and so on. Okay, Matthew, go ahead.
Okay, thank you. I was going to say, hope you've not forgotten us online. All right, then My concern is your definition of cloud computing. That is the delivery of computing services, including server storage, via the internet. I do know that we have private cloud. How do you put that together?
It's part of where we are going. It's in the subsequent slide.
Okay, no problem. Thank you.
You're welcome. I didn't forget you. You can always pause me if you have any question or you have any contribution. So, resource pooling. Resource pooling means people can share the same server with AWS as against you buying it yourself. Just like people are sharing the same Uber driver as against owning the car themselves, right? Is it clear? Then rapid elasticity. I can upgrade my car to G-Wagon within 1 minute, right? But you cannot do that if you own the car. Except you have money to buy a brand new G-Wagon. So that means if my server is of size 10, I can scale it to size 100. So within minutes. Then whatever I'm using is being measured. So I'm only charged based on what I use. Is that okay? It's like your meter, it reads based on what you are using. So if I don't own my meter, I don't get charged. So what are the benefits of cloud computing? Benefits of cloud computing. On-demand service, yeah. Pay as you go. You can go global in minutes. I can have a server in UK within 5 minutes. Meanwhile, traditional IT, I have to travel to UK, rent an office, buy server and all of that, right? Innovation, yeah. So advantage of cloud computing is minimal upfront investment. If I order Uber now, the cost is minimal, right? Compared to me buying a car. So the same thing to set up in the cloud is very cheap. So no minimal upfront investment. Ability to scale wider or reduce my infrastructure. Access to the latest technology. I can always have access to the latest version. Focus on business outcome rather than infrastructure. So our headache is not how do we ensure the server is cool, how do we pay for rent, all of that. That's not our focus. We focus on the business. Let AWS handle the infrastructure for us. Focus on business outcome, okay? Built-in redundancy and disaster recovery option. So in case of disaster, you are sure that you are safe because they have a copy of your resources elsewhere. You can have it elsewhere. Global reach, you can hit people globally. Now, what are the downsides of cloud computing? Ongoing operational cost. Now, like I said, even though we say minimal investment, it doesn't mean it's cheap. Hope you get my point. Because when you're saying, if we move from 1 million to 10 million, accommodate all of them, it's a cost, come with a cost, right? And they're saying the same information we have here, duplicate it in another location, that would be additional cost. I don't know if I'm getting my point. So, potential security and compliance concern. So, one of the concerns people have is potential security because these are going through the internet. Do you understand? So, then compliance concern. If, for example, in Europe, they don't want their data to go outside of Europe, and you want to access the resources over the internet, that might go against the compliance. I don't know if you get my point. So they may want they may not want the data from their country to go outside a particular region. So that might be a concern. Hope you get my point. Then, dependence on internet connectivity. So if there's no good internet, accessing your resources will be a challenge. So that's something that you have to plan for. Possible vendor locking. So let's say we're using AWS and we're using AWS DevOps. It means we are locking to AWS. You cannot switch. Except now to start learning the new platform, all of that. You get the idea. Not that I cannot switch per se, but the tools cannot work elsewhere. So you have to either learn a new tool, all of that. Less control over underlying infrastructure. Since you are not the one that have the physical server, it is AWS that have control over it. Hope that makes sense. All right. So we have different models of cloud services. Different model of cloud services. We have infrastructure as a service. We have platform as a service. And we have software as a service. Then now we have function as a service. We have AI as a service. And maybe very soon we'll have joy as a service. Now, but these three are the most popular one. So what does infrastructure as a service mean? It means you decide on how the infrastructure will be set up, the operating system that will be on it, the networking and everything. Is that okay? So at the level of infrastructure as a service, you have more control. Is that one clear? Platform as a service, you don't have control over the infrastructure. You only have control over the software. So your company build the software, but you don't want to have anything to do with how they set up the server, all of that, operating system. You don't want to be involved in that one. You can go for platform as a service. So they'll just give you where to put your software and everything will be fine. That's what we cover in software class. So where you just upload your Django or your React software. So you don't care about the CPU, all of that. So that's platform as a service. So software developer, most of them, they operate at the level of platform as a service. But DevOps engineer, cloud engineer, they operate at the level of infrastructure as a service. Hope that makes sense. Now, if you don't want to care about the infrastructure, you don't want to even care about building the software yourself, then you go for software as a service. Your Gmail, you don't have control over the software or the infrastructure. It's a software as a service. Netflix, software as a service. WhatsApp, Facebook, YouTube, software as a service. Is it making sense? So that means I've been using cloud even without knowing. Are the three clear? All right. So there's something they call serverless. So some organizations are now adopting the concept of serverless, where you deploy your code without being bothered about setting up a server. Then AI as a service, you can provide, organizations are now providing pre-trained model. So they have trained the model that it can do so many things. So you can just leverage on it to deploy your own application. So these are different cloud service models. So this is how to differentiate them. The one in blue is the one that you control. The one in green is the one that you cannot control. On premise, if you are using your server physically at your office, you have control over everything, right? If the server is physically in your office. If the server is infrastructure as a service, you have control over the software, the data, the runtime application, the middleware, and the operating system. When I say operating system, I mean Windows, Linux. So those are the things you have control over. You don't have control over virtualization, over the physical server, over the physical storage, over the networking of the server. You don't have control over that one. Hope that makes sense. At the level of platform as a service, you only have control over the software and the data of the software. That's the only thing you have control over. At the level of software as a service, you don't have control over anything. They control everything. Just to log in and use it. Is it clear? So when your company wants to go into developing a product, based on their need, you should be able to know which one to recommend, right? Is it clear? Go ahead. Just a minute. Okay, go ahead. On-premise means you want to have the server physically. No, security is that you have access to it. It's physically there with you. It's not just the data, because the physical server is physically there with them. Okay, it's like ordering Uber and having your own car. Your own car is physically there with you, so you can choose how you protect your car. But if I'm ordering Uber, what if in the process of coming to come and pick me, somebody attacked the person? I don't know if you get my point. The idea is that, yes, the data will be protected, but the physical server is also part of the security, not just the data alone. It's still not clear.
Server on premise. You understand? Because you are not going to be basically doing how we do tables and
It also depends on how you configure it too. As how you're able to configure that on premise, we also determine how secure it will be, even though it's on premise. I don't know if I'm getting my point. It's like somebody hacking your Wi-Fi, you know, all of those things. So somebody can also hack into your computer. But based on what you're trying to ask, it is more secure. But I may not use the word 100%. Is that okay? But remember, if there's earthquake, your secure data will be gone. So that's in the cloud. The cloud have physical location. They have physical centers. Okay, let's call it this way. Let's say I am AWS and I'm providing cloud service for all of you here, and you're a different company, right? When you pay me to host your software on this my laptop, I can say everything I put on this laptop automatically should be duplicated on my second laptop. And then my second laptop is in another location. So if there's earthquake here and this laptop is affected, at least that other laptop that is in another location, have your data there. So you can just connect to that one instead. The AWS are responsible for your data, but you telling it to be backing it up, it's your own responsibility. But they give you the facility, but you now implementing it is your responsibility because it will attract additional cost. You understand that now? If you are backing up what is on your laptop, that your hard drive is additional cost. Hope that answers your question. Now go ahead. It's your responsibility. When we talk about data in the cloud and data on the cloud? It will answer that question. So I hope this is clear. All right. So now, just a minute. Okay, so now that is cloud service models, right? They will now have cloud deployment model. So this one has to do with how you deploy now. That one is different services offered. It can be at infrastructure level, platform level, or software level, right? But when you now want to deploy, there are different models you can use to deploy. So we have the private and the public cloud, the private cloud, and the hybrid cloud. Hope it makes sense. Public, when you deploy it in the public platform. Private, when you deploy it privately. Hybrid, when you do both, either multiple cloud or both on-premise and in the cloud. So public cloud is popular option for apps, file sharing, and insensitive data storage. So when the data you are dealing with, when I say insensitive, it doesn't mean that it's not important, but it's not really like FBI information that must not ahead. So public cloud can serve such data. So it is cheaper, it is convenient, and it is fast and highly available. Disadvantage is that your data and security risk is something you have to plan for. Network performance, then limited customization. Because the public already have how they configure everything. So you are limited by what they make available. Private, most companies choose to keep their hardware in their on-premise. So advantage of this is that because they're the one that sets up the private, they can customize it to their own need. Data security, just like we have said earlier, they are in control. Legacy system, they even put old software there. But in the cloud, they may not allow old software for security reasons. I don't know if I'm getting my point. They might say your Python must be minimum of version 3. When your own personal server, you can put version 1. Hope you get my point. So that's the advantage you get. So if you're an organization that is still running old software, just go for old private cloud. So what are the disadvantages? Because you pay for everything yourself, high cost, it will be expensive. You have to buy all the server, limited scalability, there's limit to how you can scale. Compared to if it is public cloud, that you can just scale within minutes. Hybrid, you combine both. So advantage is that it's more flexible. For the one that are sensitive, you keep that one in the on-premise. The one that is not too sensitive, you put that one in public. Then you can easily scale in, scale out. Disadvantage is since you are still keeping some, you still have to maintain it, right? Then sometimes integrating them together require some technicality. So you have to get somebody who is very technical to handle that for you. So difference between cloud and traditional. In traditional, you bear the cost of the physical server, right? While in cloud, you only pay for operating the server. You are not buying it, you are not owning it, right? Because I only pay Uber for taking you to where you are going. You are not paying for buying the car. Implementing will take time in traditional, but in cloud computing, within 1 minute, I can host a server. Limited scalability in traditional, high scalability in cloud. Internal responsibility, so you maintain everything yourself. The provider maintains it for the cloud. Innovation is slow for traditional. Innovation is rapid here. Limited to physical location, traditional IT. But cloud, you have access to global resources. Resources can be underutilized in traditional. You might not even use the capacity of your server, just like your system. But in the cloud, if you are not using the capacity, just take away the one you are not using and only pay for what you are using. So you focus on managing infrastructure in traditional, while in cloud computing, you focus on your business since you are not the one managing the infrastructure. Is it clear? All right. So in summary, we've learned about cloud computing, introduction to cloud computing, different services model, different deployment model, benefit of it, and how it differs from traditional cloud. Hope I'm able to convince you and not confuse you. So we can stop here for today, or should we do some more theory? This slide, I'll make it available to you, but it's not to be shared. You are not meant to share it with another party because it's our property. I'm only giving it to you for learning purpose. Now, I won't put password. I trust that as my fellow DevOps engineers, you will work in the interest of our culture. Yeah, go ahead. Okay, come again. On-prem. Yeah, but you know, you still have what we call IP address, all of that. So, you know, if you still have to network computers together within your organization. If you are poor in networking, someone that is smart can still find a way. Or the person can come physically and try and insert hard drive, you know, all of those things. You might not be able to do it on the internet because you're not going through internet, but you can still find a way. That's why you see people go physically to bank, you know, just to see. Hope we get it now. So the next part is AWS. So we have about 15 minutes left. Should we just do some intro or we should stop here?
So sorry, how much of the theory is still left? Is this something we can complete today, or if it's not something we can complete, we can move it forward?
No, people have physical server. You can even turn your laptop to a server. It's possible. It's not that it's possible, people do it. All banks should have their own server. Yeah. And you'll be saying, you'll be in server room. I've even been to some top organizations in this Nigeria, and they give me access to their server for me to help them deploy some application. So I think we can just do a little intro so that it will reduce our theory next class. Please register your AWS account before Thursday, because I'm not a theory person, but I have to go through all of this theory for better understanding, right? So that even if you forget, you still remember some. Okay, so let's just do a little theory. Now, AWS, remember we have AWS, Azure, Google Cloud. We are using AWS for our demonstration. So it means that anything we are doing here, we also work on Azure. Is that okay? So we choose AWS because it's more popular. Is that okay? And they also offer 1 year free. Azure does not offer 1 year free. They only offer 30 days free on Azure. So that might be another advantage of we using AWS. Meaning for 1 year, you can break things. Instead of 30 days, it's almost time. So AWS, they are one of the leading cloud computing platforms in the world. And they offer wide range of services that help organizations to build, to deploy, and to manage application and infrastructure in the cloud. So they have what we call global infrastructure. So it means they have their we're almost done. When we are done, you can ask him to help you out. Now, AWS, they have physical servers in different locations. And that's also part of Star and all of that. And also, so that when your server is closed, the service is delivered faster, right? Compared to if it's coming from a far place. So what are the benefits of the cloud? We have talked about that. Cost-effective, scalability, and access to global infrastructure. So when you're dealing with AWS, their services are broken down into what we call regions, different regions. Is that okay? Like, let's use bank. Bank have headquarters, right? Then they have branches. Now, they may not use the concept of zone, but I think like religious organizations like churches, they use concept of zone. If you're not a Christian, it's just for explanation purpose. So Christians have where we call headquarters. Then that headquarters can have like a zone. Zone means different smaller churches will come together and form a zone. Then that zone can also come together and form a region. Then that region, will now report to the headquarters. So that's the same concept for AWS. So it means if I want a service on AWS, let's say I want to set up a server, I have to choose which region am I setting up that server. Hope it's clear now. Now that region is now broken down into availability zone. Meaning that if I set up a server in a particular region, I cannot say be backing up the data in another availability zone. So if anything happens to this availability zone, the backup can suffice. Is that okay? So a region on AWS, they organize their infrastructure into geographic region around the world. So a region is a physical location with multiple availability zones. So within a region, you have different availability zones. Is that okay? AZ, availability zone. So when you say AZ, that's what I'm trying to say, availability zone, AZ. So what are the characteristics of a region? What makes up a region? So a region is completely isolated from other regions. Is it clear? Just like saying states. Lagos State is a region, just an example. Abia is another region. Sokoto is another region, something like that. Is it clear? And the region can be in another country. So they have region within a country and in different countries. But the idea is that each region are isolated from each other. So any disaster in one region does not affect another region. So AWS have over 30 regions at the moment, globally. So the most popular one is US East, which is North Virginia, EU, which is Ireland, Asia Pacific, which is Tokyo, and several other ones. Different regions offer different services and pricing. It means it's possible that the service I want may not be available in a particular region. You may have to go to that region where it's available. Does it make sense? And how much they will charge you in one region may be different from another region. Example, if I create a server in region in South Africa and create a server in region in US, the price might not be the same. Hope that makes sense. So how do you choose a region? How do you know which region to choose? Who can tell us? If you want to choose a region, what are the things I need to consider? The one that is closest to you. So you have to consider proximity, how close that region is to you. What else do you need to consider? The services offered. That service you want, is it available in a particular region? So that will determine. The cost, if cost is important, so you have to weigh the cost. Yeah, that's a good one. Availability zone. Each region comprises of multiple availability zones between 3 to 6. So within a region now, you can have 3 availability zones or up to 6. Hope that makes sense. Availability zone is one or more discrete data center with redundant power, networking, and connectivity. So within an availability zone, you can have one data center or more data centers within an availability zone. Then availability zones within a region are physically separated but connected through low latency links. So that means availability zones within a region, they are separated from each other, but they are still interconnected some way. In case you need to share data, they are connected together, but they are separated because of disaster. So one disaster in one availability zone does not affect another one. Availability zones are designed, to be isolated from failures in other availability zones. Deploying across multiple availability zones is fundamental best practice for high availability. Meaning anytime you are deploying, Always deploy them in more than one availability zone in case of disaster. Hope that makes sense. Otherwise, if anything happens in that availability zone, they are not responsible for what happened. So we also have edge location, we have local zones, and we have waveless zone. So waveless zone is where they embed their service within 5G. So they partner with telecom provider to deliver this. Then while for edge location, they also have other servers closer to people than the region, just for faster connectivity and accessibility. So example of that would be CloudFront, like CDN, where when you want to visit Google now, they will look at your location. Okay, you are from Lagos. They will not look for data centers that are closer here. That's where the Google will come from, not the Google server that is from US. Hope that makes sense. So that's what I mean by edge location. It's like a company now. Let's say 365. We are doing training. We now want to spread across Nigeria. We now have another branch in Abuja, another branch in Port Harcourt. If somebody called from Delta State that I want to attend training, so can just go to Port Harcourt because that one is closer to you. If you call from the north, we just hope that makes sense. So that's the meaning of edge location, meaning they have physical location across places so that anybody that wants to access the server, they will look for your location and direct the one that is closer to you. So similar thing with local zones as well. Then they also have outposts. AWS can set up physical server on premise for you as well. So that's AWS Outpost. So we bring native AWS service to on-premise data center. So if your company needs something like that, we offer it. Now, these are the core services on AWS. So which are the ones we are going to be focusing on? They offer more than this. They offer machine learning, big data, but those are not our focus, right? So these are our focus. So at the end of this class, you should be able to know how to work with compute, which is EC2, and then EKS. So under compute, we have Lambda, which is serverless. So we'll not delve much into serverless, but it's part of the compute service they offer. So we'll focus more on EC2 and EKS. So EKS and ECS are used for container orchestration. So, but we'll focus on EKS since that's one that is more popular. Then we have storage. So we'll cover all of this storage. So how to use S3 for storage, EBS for storage, Glacier for storage. Under database, we talk about RDS and other ones. Under networking, we talk about VPC, routes. And so use Route 53 for your domain name. So if you want 35.com, so that's what you want instead of IP. So you can use that. Then CloudFront is if you want to deliver your service based on the edge location. Then management and monitoring, they offer monitoring as well, like CloudWatch. CloudWatch will be monitoring what's going on. And CloudFormation for infrastructure as code, we are not focusing on that. We are using Terraform instead. Then AWS Control Tower, if you want to set up multi-account environment. So these are the core services they offer. So we'll be picking each of these services one after the other in our next class. So, but before we close, based on the question asked before, this is the answer to the question. Customer, they are responsible for security in the cloud, AWS, they are responsible for security of the cloud, The difference is that security of those physical hardware, AWS. Security of what is inside the hardware, it is your responsibility. Is it making sense now? So like your customer data is your responsibility. If anything go wrong, it's not their fault. Your software, your operating system, your IAM access, they are your responsibility. Your networking, your firewall configuration, they are your responsibility. Your data encryption, they are your responsibility. Both the client side, the server side, the networking side, they are your responsibility. Their own responsibility is that server that they provide for you, that EC2 is their responsibility. The storage they provided for you, is their responsibility. The database that you are using is their responsibility. But the data inside the database is your responsibility. So the region, in case of earthquake, all of that is their responsibility. Hope it's clear now. All right. So in this session, we've covered overview of AWS and cloud computing concepts, how global infrastructure work, region, availability zone, edge location, service category, and responsibility that are shared. Is it clear? So our first practical will be in our next class, which is going to be under IAM, Identity and Access Management. So this will be the first practical we're going to do on AWS. That will be in our next class. So please let our 10 o'clock be 10. If you come late, you miss. Any question before we go? No question. Okay, thank you very much. Those online, I'll share the recording with us so you can revise, and I'll send us assignment as well to test our knowledge. Yes, ma'am.